Hello, STEM Nation. Jeff here, and welcome to episode number 28 of STEM on Fire, where we interview practicing professionals in the area of science, technology, engineering, and math to help guide students interested in STEM careers. If you like what you hear on this podcast, I ask that you please share it with a friend. Now let's get fired up with our guest, Kyle, and I hope our chat will help ignite your passion towards a STEM career. Kyle Ambert earned a Bachelor of Arts in Psychology and a PhD in Bioinformatics from the Oregon Health and Science University of Medicine and is currently involved in artificial intelligence and deep learning. Welcome to the show, Kyle. Fill in any gaps and share a bit of your personal life.
Yeah, thanks for having me, Jeff. I work at a major computer company who shall remain unnamed for now, but my specific work there is as a senior data scientist in our artificial intelligence products group. So I work a lot in researching the applications, the real world relevance and applications of machine learning and deep learning. When I'm not doing that, I like to spend my time playing and listening to lots of music on guitar, going for long runs and running in races.
All right, Kyle, thanks for that overview. And so you are the first artificial intelligence scientist on the show and doing a bunch of deep learning. Can you help our audience understand this actually very hot industry right now?
Yeah, I think deep learning is best understood in contrast to what I would call traditional machine learning, which hopefully some people are a little more familiar with. I can give a high-level explanation. In machine learning, we're really concerned with developing algorithms that can learn from examples. And there's a couple of different classes of machine learning. There's supervised or unsupervised learning. Let's look a little bit at just supervised machine learning. So when I'm building an algorithm to, say, recognize a picture of my dog, I might use an algorithm called support vector machine, which is really good at some image classification types of problems. But what I'm going to be doing is looking at different examples of photos. Some of them are going to be pictures of my dog, Harrison. Some of them are going to be pictures of other things. And I'm going to use my domain expertise as a Harrison expert to say, well, I know the best way to identify my dog versus other dogs and maybe versus other objects in the world. I could tell the algorithm to look for curly hair or maybe brown hair or look for a labradoodle, things like that. So that would really be the typical machine learning workflow. The data scientist is engaged in feature engineering, feature extraction with the data in question, and then ultimately training with labeled examples, an algorithm that we can then use for performing real world tasks. So deep learning is a little bit different. Instead of imposing my domain expertise on the algorithm, with deep learning, what we're trying to do is build what's called a neural network architecture that is best enabled to identify the best predictive features on its own. What that really means is neural networks is just a standard machine learning type of algorithm, but in the realm of deep learning, it's actually just a succession of layers and layers and layers of neural networks. And if for those of you in calculus right now, what makes solving deep learning possible is just a simple little tool called the chain rule, which I'm sure if you haven't encountered in calculus yet, you will before too long. And so it's just simple mathematics, but it's very deep mathematics performed at high rates of speed on a computer. So when we construct a neural network architecture or topology, as we call them in the field, in a way that can actually discover features on its own, what we found is that these algorithms trained in this way tend to outperform algorithms wherein a data scientist or a scientist is telling the algorithm which features to look for specifically.
Okay, Kyle, so you've got a bachelor's in psychology and a PhD in bioinformatics. How are those two related, and how did each one help each other?
Yeah, that's a great question. So I would say the overall theme of my career is I always just kind of start doing the next most interesting thing to me at any given time. When I was an undergraduate, I was really interested in the way the brain works, specifically how the brain and drugs interact, both for treating psychiatric diseases or just the way it just chemically how the brain just interacts on its own. And so psychology seemed like a good route to understanding that. I did a Bachelor's of Arts because at the time I actually wasn't very interested in pursuing a career in science. I kind of wanted to be a clinical psychologist. But I joined a neuroscience lab during my undergrad and did a research internship over the summer, and then kind of caught the research bug after that, and ultimately ended up pursuing a more traditional kind of science route. But when I was applying to grad school, I was still really interested in the neurosciences, and applied to join behavioral neuroscience lab up at Oregon Health and Science University, where I was studying the neural mechanisms of decision making and how drugs of abuse affect those processes. And it was a lot of what ended up being mathematical modeling and a little bit of programming. And that was all great, but I ultimately ended up developing a pretty bad rat allergy and decided that maybe bench neuroscience wasn't the best place for me at that point. But fortunately, I'd gotten really interested in the computational modeling side of neurosciences. So ultimately, that's what brought me to bioinformatics. That seemed like the best place to pursue what at the time was my next logical step in terms of what I was interested in, which would be looking into the artificial intelligence applications for the neurosciences.
So bioinformatics is neural networks, is that correct?
No, traditionally bioinformatics is defined as like computational biology or using machine learning or statistical methods to understand the genome. But a big part of that is just understanding how to do applied mathematical research. And so although my degree is in genomics and bioinformatics, my actual dissertation was more on applied mathematics and the neurosciences.
All right, Kyle, thanks for that great overview. And we're going to dig in and get into your specific area of expertise. Could you describe what your specific area of expertise is?
Yeah, well, as a data scientist, I'm sort of responsible for having a deep understanding of the mathematical tools that we want to use to solve problems. Moreover, one of the things that I bring to the table in a project is domain expertise in the area of health and life sciences. Having kind of spent the majority of my life, I guess, at this point in healthcare, going back all the way to my undergrad degree, I'm particularly enabled to speak the language of physicians and bench research scientists in a way that maybe some other engineers on my team might not be able to, or moreover, I'm equipped to understand the primary literature for the fields that we're working in. So we spend a lot of time in my group working with hospitals and with research institutions looking at genomics or predicting cardiovascular disease based off of various traits. So it's important to really understand how the domain experts that we're working with, the physicians and researchers, understand their field and the problems in their space so that we can better get at the solutions that are relevant to them.
And Kyle, for STEM Nation, for those that are thinking of artificial intelligence and deep learning, you've got psychology and bioinformatics PhD. What type of degree is also available out there that could allow a student that's interested in AI or deep learning?
Yeah, absolutely. So, yeah, that's a great question, because when I was coming up through school, a lot of the tools that we use really regularly now didn't exist. And indeed, a lot of the programs that would train somebody to do the sorts of things that I do didn't exist. Kind of had to come up through it organically. So if you're interested in artificial intelligence, there's a few different routes that you could go, depending on what you think your research interests might be, or even just the types of problems you want to work on. On the one side of things is all of the hardware involved. Artificial intelligence really pushes the limits of what we're able to do with our computational hardware. And it takes teams of experts who understand how to get the most performance out of a machine to really solve some of the problems that we're working in. So this would be the areas of like performance optimization. This is a whole field of computer science. This could be also better understanding the artificial intelligence frameworks that we use to write programs in, like TensorFlow or Caffe. So yeah, computer science is definitely just a general sort of starting point to kind of a general degree in computer science. I think would expose you to many of the opportunities that are available in the field. On my side of things, I tend to consider myself more of an applied mathematician. And so if you wanted to go that route, having a real solid grounding in mathematical sciences, up through differential equations, linear algebra, series and sequences, things like that, and then moving on, probably in grad school, maybe a bit in undergrad, deep understanding of statistics and like the general linear model, things like that, and developing the sort of the tool set for doing mathematical modeling of real world problems.
Let's go into a work day. There is no typical work day is what I'm finding out, and my day is not typical. So, but what are the type of things that you do on a day-to-day basis?
As a senior scientist, I'm usually in charge of running the technical side of many of the projects that I'm involved in. So there's a little bit of project management that I do on a day-to-day basis. This might be, keeping track of the deliverables that we've promised to the client, making sure that we're on time for all of those things. I spend at least an hour a day just in the literature. I'll see what people are talking about, maybe in the machine learning community, what new articles are out that people are chatting about on Twitter or other sources, and read a couple of those. Just to kind of stay fresh on what the conversation is in my field. Then I'll spend a good chunk of my day either in meetings with clients, helping them articulate the problems that we're going to be solving with them. I may actually be doing face-to-face site visits at hospitals, meeting with physicians, looking at how they do their job and how we might build artificial intelligence tools that would make their job easier and not necessarily just introduce new things that they have to do, but actually take on some of the repetitive tasks that maybe that they're interested in offloading. And then I'll spend a good chunk of time programming, either writing deep learning code in Python and TensorFlow, or statistical or graphical code in R.
Thanks, Kyle, for that great overview. That sounds like a pretty interesting day, and no day is going to be like the last.
Yeah.
And what is one thing that really has you fired up in the area of artificial intelligence and deep learning?
Yeah, I think right now, more than ever, there are so many opportunities to use artificial intelligence in healthcare. Healthcare as a field tends to lag a little bit behind other areas of applied engineering in terms of how we make use of technology, in part just because of regulatory issues. We will want to be really careful before we introduce a new algorithm or process into the way that we treat patients or discover diseases or things like that. But because of that, many of the new discoveries that have come out in the last couple of years are still fair game to be applied in the health and life sciences. So there's lots of opportunities there. That gets me real excited about that. I'm particularly excited about some of the results that we've seen over the last year using deep learning to discover new ways of predicting who's going to have a heart attack, for example, or come down with cardiovascular disease in some form, just based off of relatively easy to acquire genomic data that a patient could collect.
Now, Kyle, could you take us to a moment in time of an incredible aha moment you've had at work or your personal life and tell us the story and how you turn that aha moment into success?
Yeah, I will. I'll have to maybe not go into specifics too much about the actual project itself because we're still in process on it. But what I can tell you is I've been working on a project with one of our clients in the healthcare sector for over a year now. And I've been kind of beating my head against this one mathematical problem for about 4 months. And unable to solve it. We have a whole team of people trying to solve it. And yesterday morning, got up early, decided to go for a run. And then at the end of my run, I just got this idea, like about a new thing that maybe we hadn't tried. So I went to work and wrote some new code, took me maybe 20 minutes, and then tried it out. And it solved the problem completely. And what I learned from that is that as frustrating as some problems might be, if you spend a lot of time thinking about them and then just kind of let your brain do its thing in the way that it needs to do it in the back of your mind, and you've truly sort of internalized the problem, if the solution is there, your brain will arrive at it on its own in some way. And in some ways, that's the most exciting kind of discovery, I think, when you work really, really hard at something and then achieve it. that's great. But if you work really hard at something and then are able to surprise yourself with the answer, that's almost even better in my mind.
Yeah, Kyle, I'm fascinated the way the brain works as well.
Yeah.
And something that maybe you can confirm or deny. For STEMers going into college, right, some of the classes are really difficult. And I always recommend that they start their homework early, because if they can't solve it, they put it away and they start something else, the brain is going to continue to process that information. And when you come back to it, you'll probably be able to figure it out. Is that true?
I believe that to be true. Yeah. And that's certainly been my experience, at least later in life, when I maybe had a bit more consistent study habits. I think if you can start thinking about a problem when you're fresh, you're going to have fresh ideas to go at it, and certainly more tools in your tool chest for how you can attack it, even if it's just leaving it aside and doing something that clears your mind and de-stresses you, I think is also, an important approach.
All right, Kyle, and we're going to head back to when you were heading off to college to help our STEMers. Sure. What are some things that you wish you knew back then heading off to college that you think would help our STEMers launch into college successfully?
If I remember right, back when I was going to college, I was really, really concerned about what my major was going to be. What do I want to do? And those are important things to think about. Sure. It's important to have direction in life and set incremental goals for yourself. And a major is an important part of that. But I think more important is to equip yourself with a set of academic and intellectual tools to solve problems and to pursue things that are of interest to you. So for me, getting an undergrad degree in psychology in and of itself is not necessarily a recommended career move. If you want to be a psychologist, you have to keep going to grad school, get a clinical psych degree, of course. But at the time, I was really interested in psychology. And in fact, what I actually used my psych degree for didn't even exist at the time. So I think being true to yourself and to what your actual interests are, but simultaneously being realistic about what might come of that. If you're interested in studying psychology, then if you actually want to work in psychology, are you prepared to go the full route, or are you just really interested in the way the brain works? And then you'll see maybe what the next step is. So being aware of what your interests are, but also realistic about how those might be used.
Yeah, STEM Nation, any knowledge that you gain is powerful. You'll never know when that'll come into play. I mean, Kyle went for psychology. He's using that information in an industry that didn't exist back then. So thanks for that. And we're going to take a quick pause and thank our sponsor, Audible, who is offering a free audiobook. You can go to STEMOnFireBook.com to get a free audiobook of your choosing. If you decide to cancel within 30 days, there is no cost, and you keep the audiobook. And Kyle, are you ready for the lightning round?
I think so. There's no way to know for sure.
We'll find out. What's the best piece of advice you've ever received?
That's easy. My PhD advisor, Dr. Aaron Cohen at Oregon Health Science University, his advice to me early on in my research was, if you don't write or publish about what you've done, it doesn't count. And he was exactly right. You can spend a ton of time researching something and even find an important discovery. But unless you go out into the community and tell the other scientists about what you've done in a way that can be traced back to you, it may as well have never happened. You're researching in a vacuum. Research is a conversation, at least in my mind. And if you don't communicate with other colleagues in the field, then you're just sort of working there on your own. It should be collaborative, and you need to communicate what you've done.
And what is a personal habit that contributes to your success?
Oh, yeah, running for sure. I can say with confidence now. But even stepping back a little bit, engaging in things that are not work. It's important, particularly in STEM fields, which can be kind of taxing on your mind, to give yourself a mental break. Even though it might seem like it's not productive, there's work that's being done there, and it's important to be well-rounded and healthy in multiple aspects of your life.
And what would be a favorite internet resource or phone app, and why?
Oh, phone app? That's pretty easy for me. I listen to a ton of podcasts, so it's got to be the podcast app. On the internet, I spend a fair amount of time on math and science Twitter, as well as Reddit has some really interesting conversations. /r/machine learning is a site that I frequent. A lot of interesting dynamic information about artificial intelligence going on there.
And if you could recommend one book, what would it be?
My favorite fiction book is Infinite Jest by David Foster Wallace. It's really, it's a bit of a thick read, but it's really funny and incorporates optical physics in a way that actually seems natural. So I quite enjoy that book. In terms of in my own field, I'd say right now I'm really been enjoying the deep learning textbook from Goodfellow and Bengio.
All right, Kyle, and as we wrap up here, can you share a parting piece of guidance for STEM Nation, and then we will say goodbye?
Yeah, parting piece of guidance, stay true to yourself and your interests, be engaged in your community and aware of the discoveries that are happening around you and how you can be a part of them.
All right, thanks for that, Kyle, and we will say goodbye. I hope you enjoyed our discussion today with Kyle. Head on over to STEMonfire.com, subscribe to the email list to keep up with the latest happenings, and be sure to subscribe to the podcast on your favorite podcast player. And again, if you're getting value from this podcast, please share it with a friend. Tune in next week where we talk with Christine, who is an actuary and also on the hit show Survivor. Until next time, I hope this chat has helped ignite your passion towards a STEM career.